Hello math enthusiasts, welcome to MathGlider, where we glide mathematics right into your mind. Welcome to part 2 of the video, set theory and logic. Let us look at some logic today. You know the meaning of statement. Statement is a sentence with some truth value. The sentence which will be either true or false and not both at the same time. Your statement can be a mathematical statement or a vague English statement also. This logic applies to both kind of statements. So you have a logical connective to connect two statements. If you have two statements, we connect those by these logical connectives. First of all, we have conjunction. Conjunction means in between two statements we attach and P and Q. Truth value of P and Q is true if both P and Q are true. Disjunction. Disjunction means we attach or in between two statements P or Q, and truth value of P or Q is true if either one of them, at least P is true or Q is true. If both are false, then truth value is false. Negation. Negation means we attach the word not in between the statement. Like we flip the truth value. If originally statement was true, we make it false, and if originally statement was false, we make it true. We have the De Morgan's law for relation between the and not. If we have a statement P and Q and we make its negation, it will be negation P or negation Q. And if we have P or Q and its negation, we take its negation, then it will be negation P and negation Q. Look how the and becomes or when we attach the negation side inside. De Morgan's law are essential for simplifying the logical expressions and reasoning of some proofs involving logic. Now we look at some conditional and biconditional. Conditional statement, we have P and this kind of arrow towards Q. This means P or Q. Oh sorry, if P then Q. Okay, we read it as P implies Q, and this statement also we read it like if P happens then Q happens. The truth value of this P implies Q, the logic table, it is same logic table as negation P or Q. You can check it. Biconditional statement means P if and only if Q. We had if P then Q, like P implies Q, but we attach another condition also, like P implies Q and Q implies P, and then it becomes P if and only if Q. That is also mean by biconditional. So you know these two things are equivalent, P if and only if Q and P implies Q and Q implies P. You can check this also. You can study the logic tables or truth tables of this P and Q and P if and only if Q. Now we have a converse, inverse and contrapositive of the statements. If we have a statement P implies Q, its converse will be Q implies P. This is very important in proofs. Many a times we have a proof like this statement implies this, and we always think if converse is true. Inverse of the statement. If we have a statement P implies Q, its inverse is negation P implies negation Q. Like we attach negation on the same statement. Contrapositive. Contrapositive means it is a converse of an inverse. You can say it like that. Contrapositive is if we have a statement P implies Q, then contrapositive is negation Q implies negation P. You can check this on your own. The truth value of P implies Q and its contrapositive negation Q implies negation P are same, and this converse and the inverse, they have same truth value. But converse and the original statement need not have the same truth value. Okay, this is what it is written. The original statement and its contrapositive are logically equivalent. That means they have a same truth value or the same truth table, and converse and inverse are logically equivalent, but they need not be equivalent to the original statement. Now we have some proof techniques that we will use in this course on real analysis, or you can say mathematical analysis. So first of all, we have direct proof technique. Like, well, whatever we want to prove, we prove it directly. If you want to prove P implies Q, then we assume P and then we derive Q somehow. Contrapositive means if the P implies Q and negation Q implies negation P are two logically equivalent statements. So if you want to prove P implies Q, you can also prove negation Q implies negation P, and your work is done. Third technique will be your contradiction. This is really important in this course. So we will often use this technique of contradiction. If you want to prove some thing, like we want to prove the statement P, we will assume negation P is true. Okay, originally we wanted to prove that P is true, and we have assumed negation P is true, and then we will get some contradiction. Contradiction is something which is not possible, which is like something wrong happens when we assume that P is not true, and then we will derive that if negation P is not true, that means P is true. This technique is called contradiction, and we will use it very often. Fourth technique you will use often is induction. Induction is like steps you are using to prove. First of all, you will prove the first step. In induction, you will have some general statement P of n for all n, and you will prove the first step. Like the second step also can be first step, depending upon your choice of your statements or choice of your the first step. So we will prove that for n is equal to 1, that statement is true. Then you will assume that for any next step, then 1, 2, 3, 4, it can be anything. We will assume that it is true for that k, and then we will prove that the next step, the k plus 1 step, is true. And by the induction, like we proved the first step is true, then we can derive that second step is true, third step is true, and by the induction we can prove that it is true for all n. So this is the technique called induction. So these are the all proof techniques you will use. So thank you so much for watching the video, and please subscribe to my channel, like the video and share with your friends.